Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 2 video on the chapter of operations on algebraic expressions, where I will discuss about multiplications of algebraic expressions. That is how we multiply two algebraic expressions, which will be based on the product of finding the product of two monomials, product of a monomial and a binomial, product of two binomials, and finally the product of two polynomials. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are not yet subscribed and if you are watching my videos regularly, or if you are visiting my channel for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes prepared on the topic of finding the product of two algebraic expressions. This is a very quick notes. The link of the PDF of these notes will be given in the description below. You can check the PDF from that link. While I will discuss the topic, I will refer my quick notes. And I will not discuss the examples given in the quick notes, but I will do the discussion using some another examples. Okay, so this is about finding the multiplication or product of two algebraic expressions. In the part 1 video, I gave a very brief introduction about algebraic expressions that you have already studied in your previous class 7, regarding what is an algebraic expression, what are terms, factors, literal coefficient, coefficient of a term, all those things, like terms, unlike terms, addition and subtraction of algebraic expressions, addition and subtraction of terms. I have discussed in part 1. If you have not watched part 1, I strongly suggest that you also watch that video. Okay, so multiplication of two algebraic expressions is based on some fundamental concept. The first one is how do we find the product of two monomial. So what is a monomial? A monomial is basically a term. That is, and what is a term? A term is a product of one or more literal factors or numerical factors, like x square. These are all monomials, like 4 by 3 a b square, where a, b, x are variables. You can have minus 0.01 p cube, and you can also have, let's say, square root of 4, square root of 5. So these square root of 5 x y square and z cube. So these are all monomials. That is, a monomial is basically a term. So how do we find the product of two monomials? So let's say if we have to find the product of these two monomials, how do we find the product? So a term is a term consists a term has two major parts. One is the coefficient, or the numerical coefficient, and the other is the literal coefficient. For example, if you consider 4 by 3 ab square, the numerical coefficient is 4 by 3, and the literal coefficient is ab square. Likewise, let's say minus x square. For minus x square, the numerical coefficient is minus 1 and the literal coefficient is x square. So when we find the product of two monomials, where monomials is basically term. So when we find the product of two terms, we first find the product of the two coefficient of the two terms. So for minus x square, the coefficient of the term minus x square is minus 1, and the coefficient of the term 4 by 3 ab square is 4 by 3. So the product of the coefficients of the two terms will be the final coefficient of the final product. other term. So product of two monomials gives another monomial, or in other words, product of two terms gives another term. So this will be the numerical coefficient of the final product. Now, what will be its literal coefficient? We then multiply the literal coefficient of the two terms, that is the two monomials. The literal coefficient of the first monomial is x square, and the literal coefficient of the second term is ab square. ab square. So the numerical coefficient is easy. We know this will be minus 4 by 3. And how do we find the product of the literal coefficients? So literal coefficients will have literal coefficient of a term or a monomial will have multiple literal factors. We will combine the similar factors. By similar factors, I mean the literal is same. So we will combine all the powers of x. We have only x square. So this is x square. And so this becomes x square a b square, because there is only a single powers of the variables x, a and b. So finally the product becomes minus 4 x square a b square by 3. Now let's take the example of let's say how do we let's say this is example 1. How do we find the product of this monomial, that is minus x square, and square root of 5 and x, y square and z cube? So first we find the product of the numerical coefficients of both the monomials. So we have minus 1 multiplied by square root of 5. So this becomes the coefficient or numerical coefficient of the final term or the product or the result. Then we multiply the literal coefficients of both the monomials or terms. So x square is the literal coefficient of the monomial minus x square, and x, y square, z cube is the literal coefficient of the second monomial. So this becomes minus root 5. Minus 1 into root 5 is minus root 5, and then from the product of the two literal coefficients, we combine all the similar literal factors. So we see we have x square into x, so it becomes x cube. There is only single terms of y and z, so it is y square and z cube. Hence the final result is minus negative of square root of 5 x cube, y square and z cube. So this is how we find the product of two monomials. We find the numerical coefficient of the final result will be the product of the numerical coefficients of the two monomials, and the literal coefficient of the result will be the product of the literal coefficients of the two monomials. And in finding the literal coefficient, product of the two literal coefficients, we merge the powers of the similar factors, similar literals or variables. Okay. Now, so this was product of two monomials. The next is in the quick notes. It is the next topic is product of two binomials. But before that, so this was about this was monomial multiplied by another monomial. Monomial means an algebraic expression with a single term. So you can always say that a monomial is also a term. Okay. Now let's discuss how do we find the product of a monomial and a binomial. So monomial, product of a monomial and a binomial. A binomial is a algebraic expression with two terms. So let's say for this we will use the distributive property of multiplication over addition and subtraction. So let's say so we know that the distributive property of multiplication over addition and subtraction is that we know the result is a multiplied by b plus c. If you have an expression a multiplied by b plus c, this will be equal to a multiplied by b plus a multiplied by c. We know this, you already know these results, a distributive property of multiplication over addition and subtraction on the rational numbers. It also works for algebraic expressions where here a, b and c, they can be a constant number, they can be a variable, they can be they can also be a term. Okay. Also, multiplication is distributive over subtraction. So, if it was a multiplied by b minus c is equal to a multiplied by b minus a multiplied by c. We will use these two properties in finding the product of a monomial and a binomial. So, let us say we have to find the product of minus 4, let us say a b square. This is a monomial, and we have to find the product of this monomial with another binomial, let us say minus ab plus let us say b cube. So, minus ab plus b cube is a binomial, it has two terms. The first term is minus ab and the second term is b cube. So, consider this as a with reference to this these two properties of distributivity of multiplication over addition and subtraction. Consider the minus 4ab square, that is a monomial, as the a, and as we can see the binomial is minus ab plus b cube. So, we can consider this as b and this as c. So, this will become minus, as we know it is a into b. So, minus 4ab square multiplied by b is minus ab, and plus we have minus 4ab square multiplied by c is b cube. Now, we have to find the product of two monomials. So, minus 4ab square multiplied by minus ab will be, we first multiply the coefficients of the two monomials. So, minus 4 multiplied by minus 1, and then we multiply the literal coefficients, that is ab square multiplied by ab. So, this was now the second the product of the second two monomials will become minus 4, and the numerical coefficient of the monomial b cube is 1. So, it is not necessary to multiply 1 with minus 4. Now, the product of literal coefficients of the two monomials, it is ab square multiplied by b cube. If you further simplify, minus 4 into minus 1 is 4, and if you the product of the two literal coefficients, that is ab square multiplied by ab, if you merge the powers of a and the powers of b, it becomes a into a becomes a square, a into a becomes a square, and b square into b becomes b cube. So, your laws of exponents must be very clear and thorough. Okay. So, this was this, and the second one we have minus 4 multiplied by we have a and multiplied by b square into b cube, that is b to the power 5. So, this becomes 4 a square b cube, since it is minus 4 minus 4 a b to the power 5. So, this is the result. Okay, let us take another example. Let us say we have let us say we have to find the product of a binomial, let us say mn square, let us say plus m cube multiplied by the monomial, let us say minus m n let us say m square and minus m square n square. So, the first term, the first expression, this is a binomial and this is a monomial. So now you will consider you will apply the distributive law of multiplication over addition. So consider this as the A, this as A, and consider this as B plus C. So the result will be A into, we know that A into B plus A into C. So what is A? A is minus m square n square. A into B is m n square, and then plus again minus plus A into C. So the result will be A into B plus A into C. A into C will be minus m square n square multiplied by C. In this example is m cube. So now we have to find the product of two monomials. Now this will be minus 1 multiplied by 1. So the numerical coefficient of the monomial minus m square n square is minus 1, and the numerical coefficient of the monomial m n square is 1. So minus 1 into 1, and then we have to find the product of the literal coefficients of the two monomials, that is m square, m n square, and m n square. Now the second one, the literal coefficient, the numerical coefficient of the first monomial is again minus 1, and the numerical coefficient of the monomial m cube is 1. Now we will find the literal product of the two product of the literal coefficients of the two monomials. So that will be m square n square multiplied by m cube. In further simplification, we get minus of minus 1 into 1 is minus 1. Now if you merge the powers of m, we will get m square multiplied by m, that is m cube, and n square multiplied by n square is n to the power 4. For the second one, the coefficient is minus 1 into 1, which is minus 1, and m square into m cube is m to the power 5 and n square. So this is the result. So this is how we find the product of a monomial and a binomial. Now how do we find the product of two binomials? So these are all the fundamental concepts that will be required in finding the product of two algebraic expressions, where an algebraic expressions can have 1, 2, 3, 4, any number of terms. So let's now see how do we do binomial, product of two binomial. Okay. In this we have to use the distributive law of multiplication over subtraction and addition twice. How? Let's say we have a binomial. So let's say we have, how do we do a plus b multiplied by let's say c plus d, where a, b, c, d could be numbers, constants, they could be a single variable, that is a literal, that is x, y, z, any variable, or they could be some terms, or even they could be algebraic expressions. Now the thing is that you consider so this is the product of two let's say two binomials. You consider this as a and this as b plus c. So this will be equal to, we know that a multiplied by b plus c using the distributive law of multiplication of addition is equal to a multiplied by b plus a multiplied by c. Now this way of finding the product is known as horizontal method, using the distributive law of multiplication over addition and subtraction. This is also known as horizontal method of finding the product of two algebraic expressions. So we know a multiplied by b plus c is a multiplied by b plus a multiplied by c. So first we have considered the first binomial, that is a plus b, as a, and the second binomial c plus d as b plus c. So so it is now A multiplied by B plus C. So this will be A, we know is A plus B, multiplied by C, multiplied by B is B, in this example is C plus again A is in this example A plus B multiplied by D. So now again you see we have A plus B multiplied by C, that is a product of a monomial and binomial. So again we will have to apply the law of distributive law of multiplication over addition. So this will be A multiplied by C plus B multiplied by C, and we have over here A multiplied by D plus B multiplied by D. So this becomes equals to AC plus BC plus AD plus BD. So this is how we will multiply two binomials. Now let's consider an example using algebraic expressions. Okay, let's say we have to multiply, let's say m square plus n square. This is one binomial where m and n are variables. We have to find the product of this binomial with, let's say, n minus n m. So n minus m is also a binomial having two terms. First term is n and the second term is minus m. And for the first binomial m square plus n square, the first term is m square and the second term is n square. So how do we find the product? So you consider this as A and this as B minus C. Since the binomial is n minus m, consider it as B minus C. And now we know that A multiplied by B minus C is equal to A multiplied by B minus A multiplied by C. Using this concept, it will be m square plus n square multiplied by n minus m square plus n square multiplied by m. Now again we will have to apply the concept of finding the product of a monomial and a binomial that we already discussed. So this will be m square n plus n square. So this will be m square into n plus n square into n minus we have m square into m plus n square into m. Now if you open the brackets and simplify further, we get m square n plus n cube, and we have m cube minus m n square. So this is the final result. This is how we do binomial to the product of two binomials. So this was an example, m square plus n square multiplied by n minus m. Now let's see let's see another example. Let's say we have x minus let's say yx multiplied by, let's say, y square plus x. So we have the first binomial is x minus yx and the second binomial is y square plus x. So this will be consider this as A and consider this as B plus C. So this will be x minus yx multiplied by B, that is y square, plus x minus yx multiplied by C, that is x. Now again we have to apply the concept of distributivity of multiplication over subtraction, because we have x minus yx multiplied by y square. So this becomes x multiplied by y square minus yx multiplied by y square, and we have plus x multiplied by x minus yx multiplied by x. So this is equal to x y square minus y cube x plus x square minus y x's square. So this is the final result. So this was how we do the product of multiplication of two binomials. So we discussed product of two binomials, product of monomial with a binomial, and product of two monomials. Using these concepts, we have to find the product of two algebraic expressions. But before that, we need to discuss one more thing, that is product of a monomial and a polynomial. A polynomial is an algebraic expression having having one or more, having two or three or more terms. So now let's discuss monomial. How do we find the product of a monomial and a polynomial? Okay, let's say we have to, I'm taking a concrete example. Let's say we have to find the product of x, let's say the monomial is x cube and y square, and we have to find the product of this monomial, that is minus x cube y square, and the polynomial, which is basically an algebraic expression, polynomial b, let's say y minus x plus x y. So this polynomial is having three terms. First term is y, second term is minus x, and the third term is xy. So how do we find the product of the monomial and a polynomial? You find the product of this monomial with all the terms of the polynomial. That is, you will find the product of the monomial with the first term, and then, I'm really sorry my weird way of explanation, but I hope you will get the idea. So you will find the product of the monomial with all the three terms of the polynomial, and then you will add the product. So you will add the product. So this will be equal to minus x cube y square multiplied by y plus again minus x cube y square multiplied by the second term of the polynomial, that is minus x, plus the product of the monomial and the third term of the polynomial, that is xy. Similar way, if there was more than three terms, you will do the same thing. You will find first the product of the monomial with all the terms of the polynomial, and then you will add the results, add the products. So this will be, I will now straight away write the results. This will be minus x cube y cube. This will be minus the second term for the second product, minus minus will cancel out. This will be x to the power 4 y square, and the third term, since the numerical coefficient of the first monomial is minus 1, will be minus x to the power 4 and y cube. This is the result. Okay, let's take another example. Let's say we have let's say a b plus b square minus, let's say, a plus b. So this is a algebraic expression or a polynomial having four terms, where the first term is ab, the second term is b square, the third term is minus a, and the fourth term is b. We have to find the product of this algebraic expression with a monomial. Let's say the monomial b minus ab. The monomial is minus ab. So you just find the product of the monomial minus ab with all the terms of the polynomial and add them. So this will be ab multiplied by minus ab plus b square multiplied by minus ab plus minus a into minus ab plus b into minus ab. So this is equal to AB multiplied by minus AB is minus A square B square. Then B square multiplied by minus AB is minus A B cube. And minus A multiplied by minus AB is A square B. And finally, B into minus AB is minus A B square. So this is the final result. So this is how we find the product of a monomial and a polynomial. Now we are good to find, good to discuss how do we find the product of two algebraic expressions. Where algebraic expressions you can consider it as a polynomial. So, so finally we have polynomial product of two polynomial. Product of two polynomial. Okay, let me see quickly if everything is visible or not. Okay, now let's see how do we find the product of two polynomials. In the notes, you can. I am not going through the. I will not go through the notes. Let's try to understand with a concrete example. Now, a polynomial will be a algebraic expression. So let's say we have to find the two algebraic expressions are, let's say, minus A plus B square minus AB. So the first polynomial is minus A plus B square minus AB, and the second polynomial, let's say, is B plus A square and minus, let's say, B square. So we have to find the product of these two polynomials, where each polynomial is having, let's take a little more complex example. Let's say the second polynomial has 4 terms, let's say plus AB. So the first polynomial has 3 terms. The terms are minus A, B square and minus AB. And the second polynomial has 4 terms. The terms are B, A square, minus B square and AB. So how do we find the product? You can do it 2 ways. The one way is that you consider you find the product of the left polynomial with each term of the second polynomial and add the results, add the products. That is, let's say you find the product of the left polynomial with each term of the left of the right hand polynomial, and then you add the results. I am trying my best to visually explain how will the product look like. Not look like, but how will the product be performed. So this means that I am trying to say that the left polynomial, that is the polynomial having 3 terms, that is minus A plus B square minus AB, you find the product of that polynomial with each term of the right hand of the second polynomial, and then you add all those products. So this becomes, now you could have also done the other way around. That is, you could have find the product of the right hand, the second polynomial with each term of the left of the first polynomial and add the results. It will give the same thing. It will give the same result, same value. Both way is fine. So this will be minus A plus B square minus AB multiplied by the first term of the second polynomial, that is B, then again minus A plus B square minus AB, product of the first polynomial with the second term of the second polynomial, that is A square, and then again minus A plus B square minus AB multiplied by the third term of the second polynomial, that is minus b square, and finally minus a plus b square minus ab multiplied by the fourth term of the second polynomial, that is ab. Now we have to we have to find the product of monomial and polynomial and then add the results. I am doing it directly. So for the first product of monomial and the polynomial, it will be minus a b plus b cube minus a b square, and for the product of the second the second product of the monomial and the polynomial is minus a cube plus b square a square minus a cube b. Similarly, the third one will be a b square minus b cube plus a b cube, and the last result, the product of the monomial ab and the polynomial, first polynomial, will be minus a square b plus a b cube minus a square b square. So now you have all the terms. You have to add up the like terms and do further simplification, which I will not do. I hope you know how to do that. You have to add up all the like terms, group the like terms, and add them up. So this was, I hope you understood how do we multiply two polynomials or find the product of two algebraic expressions. Now let's solve some selected problems from the exercise of 6B from the textbook of author RS Aggarwal to apply the concepts that we just learned, that is in finding the product of algebraic expressions. Let me see if you can see the exercise B problems or not. Okay, you can see it. I will not do solve all the problems, that will take a lot of time. I will do some selected problems. Okay, so problem number 1 is 5x plus 7 multiplied by 3x plus 4. So this is a product of two binomial. So you can visually, even though you will not mark, let's say I'm considering this as A and this as B plus C. For the sake of it will help me in writing in doing the calculation. But I hope even the exams, while solving, you will not mark this A and B and C. So this will be equal to I know that A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. So this will be 5x plus 7 multiplied by 3x and plus 5x plus 7 multiplied by 4. Again 5x plus 7 multiplied by 3x will be 5x multiplied by 3x plus 7 multiplied by 3x. We have plus 5x multiplied by 4 and plus 7 multiplied by 4. This is equal to 15x square plus 21x plus 20x plus 28. Now always group the like terms and add them up. So this is 15x square and 21x plus 20x is 41x and we have 28. So this is the final result of the product of the two given binomial. This was product of two binomial. Okay, let's do so While I'm solving the problem, you can pause the video and take a screenshot if you think it will help you. Let's do problem number 2. This is 4x plus 9 and multiplied by x minus 6. Now in the first problem, I considered the first binomial as a and the second binomial as b plus c. You can also do the other way around. So let's say I am considering this as a and this as b plus c. So this will be equal to a into b, that is x minus 6 into b, that is 4x, and we have plus a into c. A into c. C is 9. Okay. This is equal to again x into 4x minus 4x. You can consider this as the better way of writing it is 4x multiplied by minus 6, and then we have 9 multiplied by x plus 9 multiplied by minus 6. So this is equal to 4x square. Now 4x multiplied by minus 6 is minus 24x plus 9x minus 54. So this is equal to 4x square minus 24x plus 9x is equal to minus 15x and minus 54. Now I could be doing some calculation mistake. I could be doing some silly mistake in calculation. I'm not really focusing in that. Please try to understand the concept or the procedure, how I am finding the product. Okay, let's do problem number 4. 3y minus 8 multiplied by 5y minus 1. It doesn't really matter which one you consider as a and which one you consider it as b plus c or b minus v. The result will be same. I'm considering this as a, considering this as b minus c. Since this is a product of two binomials, so this will be equal to a into b, that is 3y minus 8 multiplied by 5y. A into b minus, we will have a into c, that is 3y minus 8 and c is 1. C is 1. Okay. So again we have 3y minus 8 multiplied by 5y. So this is 3y multiplied by 5y and minus 8 multiplied by 5y, and we have minus of basically 3y minus 8. So this is equal to 15y square minus 40y, and if you open the bracket of the last term, last expression, it will be minus 3y and plus 8. Now add up the like terms, that is add up the minus 40y and 3y, we get minus 43y plus 8. So this is the final result. Okay. Let's do problem number 13. It is x to the power 4 plus y to the power 4 multiplied by x square minus y square. So this is also a product of two binomial. So let's say I'm considering this as a and this as b plus c. I know the result will be a into b plus b into c. So I have a into b plus a into c, a into c. This will be again x square multiplied by x to the power 4 minus y square multiplied by x to the power 4. And for the second product, it will be x square multiplied by y to the power 4 minus y square multiplied by y to the power 4. This is equal to, out of further simplification, x to the power 6 minus x to the power 4 y square plus y to the power 4 x square and minus y to the power 6. So this is the final result. Okay, let's do problem number 14. This is x to the power 4 plus 1 by x to the power 4 multiplied by x plus 1 by x. Okay, so let's say this, consider this as a and this as b plus c. B plus c. I know it will be a into b plus a into c. So x to the power 4 plus 1 by x to the power 4 multiplied by x. This is a into b and plus a into c. We have x to the power 4 plus 1 by x to the power 4 multiplied by 1 by x. This again further using the distributive law of multiplication or addition, we get x multiplied by x to the power 4 plus x multiplied by 1 by x to the power 4, and we have x to the power 4 multiplied by 1 by x plus 1 by x to the power 4 multiplied by 1 by x. So this becomes x to the power 5 plus x multiplied by 1 by x to the power 4 is 1 by x to the power x cube, and we have x cube plus 1 by x to the power 5. So for better readability, you can group the same power of x. You can write it like this, which will look good. So this is the final result. Okay, let's do problem number 15. Now we have these are all product of two polynomials, that is two algebraic expressions. They could be binomial and polynomial, or even two polynomial. X square minus 3x plus 7 multiplied by 2x plus 3. Now, as I said, as I discussed, so this is a polynomial and a product of polynomial and a binomial. So you can consider finding the product of this polynomial with each term of the binomial, finding the product. Now I am marking this visual just for the sake of discussion. Please do not solve in solving the problem in your exam. Please do not use this arrow marks or the multiplication sign. So this is equal to x square minus 3x plus 7 multiplied by 2x plus x square minus 3x plus 7 multiplied by 3. So this again is equal to x square multiplied by 2x, and minus we have 3x multiplied by 2x plus 2x multiplied by 7, and plus 3 multiplied by x square minus 3 into 3x plus 7 into 3. So this is equal to 2x cube minus 6x square plus 14x plus 3x square minus 9x plus 21. Now you must add up the similar terms. Minus 6x square plus 3x square is minus 3x square. 14x plus 9x is equal to plus 6x. Sorry, plus 5x, and we have plus 21. This is the final result. Okay, let's do problem number 16. Problem number 16 is again a product of a polynomial and a binomial. Now this time, as I said, you can either find the product of the first polynomial with each term of the second polynomial and add the products, or you can find the product of the second polynomial with each term of the first polynomial and add the products. So for this problem 16, let's do it in a different way. Let's find the product of this polynomial with each term of the first polynomial. So this will be equal to 3x minus 5. This is the second polynomial multiplied by with the first term of the first polynomial 3x square, and then again the product of the second polynomial with the second term of the first polynomial 5x, and then again the product of the second polynomial with the last term of the first polynomial, that is minus 9. So this is equal to, again we have a product of a monomial and a binomial, 3x square minus 5 3x square plus 3x multiplied by 5x minus 5 into 5x plus 3x into minus 9 minus 5 into minus 9. So this is equal to 9x cube minus 15x square plus 15x square minus 25x minus 27x plus 45. This is equal to 9x cube, 15x square cancels out, and minus 25x minus 27x is minus 52x, and we have plus 45. This is the final result. Okay. Next is 22. 22 is again a polynomial, product of a polynomial and a binomial. We have this. So let's find the product of the second polynomial with each term of the first polynomial and add the products. So this will be equal to x square minus 3 multiplied by x cube and then we have plus x square minus 3 multiplied by minus 5x square, and then we have x square minus 3 multiplied by 3x, and then finally we have x square minus 3 multiplied by 1. So this is again is equal to x square multiplied by x cube and minus 3 into x cube. We have plus x square multiplied by minus 5x square plus can say minus 3 into minus 5x square plus x square into 3x minus 3 into 3x, and finally plus x square minus 3. This is equal to x to the power 5 minus 3x to the power cube minus 10x to the power 4 plus 15x square plus 3x to the power 3 minus 9x plus x square minus 3. Now you have to add up the similar terms. We can see 50x square. Okay, so we have x to the power 5 and we see minus 3x cube and plus 3x cube, they cancels out, and we see minus 10 x to the power 4, and we have 50x square plus x square, that is 16x square, and we have minus 9x and minus 3. So this is the final result. Okay, let's do problem number 23. Problem number 23 is a product of two polynomials, where each polynomial is an algebraic expression having three terms. So we have 3x plus 2y minus 4 multiplied by x minus y plus 2. Let us now consider, okay, we multiply the second polynomial with each term of the first polynomial and add the results, add the products. So this becomes equal to 3x multiplied by x minus y plus 2 plus 2y multiplied by x minus y plus 2, and finally minus 4 multiplied by x minus y plus 2. Now we have to find the product of a monomial and a polynomial. So this is 3x into x minus 3x into y plus 3x into 2. Then we have plus 2y into x minus 2y into y plus 2y into 2, and then minus 4 into x plus 4 into y and minus 4 into 2. This becomes 3x square minus 3xy plus 6x plus 2xy minus 2y square plus 4y minus 4x plus 4y minus 8. Okay, so this is equal to 3x square. We have to add up the similar terms. So we can see minus 3xy and plus 2xy, that makes minus xy. Then see a minus 2y square, and then we see 6x plus minus 4x, that is 2x, and we see plus 4y and plus 4y, that is 8y, and BC minus 8. This is the final result. Okay. Now I hope you can do 25. 25 is very similar to 23. I'm not doing 25, and I am also not doing 26, because 25, 26 is very similar to 23. If you can understand 23, you can easily do 25 and 26. So this brings to an end in solving some selected problems of exercise 6B. So in this video, I have discussed about the multiplication of two algebraic expressions, and the fundamental concepts were to understand the product of two monomial, a product of a monomial and a binomial, product of two binomial, and product of a monomial with a polynomial, and finally product of two polynomials. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also please once again support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about how we do division of two algebraic expressions. So please stay tuned for the next video, and in that video I will also solve some selected problems of exercise 6C, which is based on division of algebraic expressions. So thanks for watching, and until the next video, take care and bye.